Okay, today I only have a little while, probably 20 minutes, maybe half an hour. And what I'm going to do is I'm going to try to teach myself how to do some volume work in Blender by creating a volume, then having that volume, sampling in that volume, and then displacing points based on their position in there. This is all lead up to attempting to then use the points to accumulate field values and then distort. I really want to learn how to do this type of thing. I don't anticipate any of this is going to be terribly exciting or beautiful, but I am interested in learning some of the constraints that go into it. What I'm going to start with is I'm going to start, and I'm going to start playing some Mike Keneally while I do this. I am going to start with a scene that I experimented with earlier. This is gravity sources, and so what I did in this, this is all reasonably primitive is not the word I want to use, but it's certainly beginner level. What I did was I set up, and it took me a while to figure out how to do this, but I set up a couple different sets of geometry nodes. The first one that I worked with was this. This is a gravity source. And here what I've got is I've got a group input, and it has an x, y, and a z. I combine those into a vector, and then I take a UV sphere. I instance the UV sphere here at that location, and then I output it. This is pretty straightforward. In fact, there's probably a much simpler way to do this, but what I wanted was I wanted this to be all confined inside a single thing so that I could have this gravity source here. Now, you'll see that the end result, which I haven't gotten to yet, is that, and it says gravity source, but really it's repulsive. And in fact, it's repulsive in a single direction. It's all messed up. It's not that amazing. But I've got it so that I can adjust the position here. And you'll see if I do that, the lines move. So that's the gravity source right here. And then what I did was I built out a curved line. And this one is where things get a little bit tricky. So what I did was I created a group input that accepted count, which is really the number of instances that we want on our line. The number of points in the line that we're integrating. I then say where does it start, and then I say the start point just comes in as a position. Then I add to that 1 in the z direction, so everything goes directly up. I then take the final result from that, the curve. I turn that into points, and this is where I do some stuff to it. So what I've got is I've got the geometry proximity, so the nearest, and see here it's doing faces. And this is where things don't exactly work the way that I should do, and we'll adjust that in a minute. What I've got is I have it accepting the geometry, finds the nearest face, then it takes the distance to that as the base, so 1 over r squared. It multiplies that by the position, so it's straight vector position, and that's why it's asymmetric around the axes. I add that to the position, I then set the position of the output, and then I turn that into a curve, and then I output that. And so that's really, I mean, it's not super clever or amazing, and in fact it doesn't necessarily do even what we want it to. And then this took me a while to figure out, and I'm not sure that I'm doing it exactly right. So what I do is I input a group geometry. One of them is the source. One of them is the one of them is the source, and the other is my gravity source. So here this geometry goes in for each element here. I compute the index. I then sample the position on that index, and I supply that as a start point. So here, every point in my input geometry gets fed in as the starting point of a line that then extends up by 1 in the curved line set. So the ultimate result of this is that I create a plane here at 1.5 meter, 1.5 meter, 10 in the x, 10 in the y, and I feed that in as a geometry. Now for every point in that plane, it computes this curved line. And so what it does is it takes the gravity source, it takes every single point, it creates 26 points along each line, and then it joins the output geometry. So I don't know why I've got this value right there. And so this is sort of a starting point for me learning how to take these different values, take these this set of values along a grid and then modify them. Okay, so let's go back here. What I want to do is I want to convert this first into a script. That's ultimately what I want to do. I'm going to do one more experiment before I get to that point here, and I'll save that. And here, what I want to do is I want to see if we can do something similar with points inside a volume. So we'll create our geometry, we'll create a volume cube, and then I'm going to sample points inside that volume. So here we'll take our volume, and then for now, let's do geometry instances, instance on points. So we'll instance on our points, we'll take our points there, we'll just get rid of our group input, and then we'll output those. Now for our instances, we'll do a UV sphere, and I'm going to make this pretty low resolution because I don't want to end up in a situation where let's do 0.1, where I have like basically crashing. So we've got these, they're randomly distributed. I'm going to up the density, and actually I'm going to change it to a grid distribution. So we've got this grid of spheres, and they're all low resolution spheres, no volume to speak of. So this is our, and I'm going to save this now. This will be volume gravity. What we'll do, why did it not save? Okay, so let's take this. And now I'm going to create a new, I don't remember how to, all right, well, let's just create a new. All right, now I'm in geometry nodes 1. We'll do gravity, say gravitational force here. And so what this will do is we will accept an input, geometry, and then we are going to take our vector math, we'll compute the distance between some input and our geometry. Oop, that's an invalid link. Any invalid links are highlighted. So instead, let's go ahead and we will read our position from our geometry. Okay, so that'll be our distance. And so now GMM over R is our output. We'll make this, we'll do a math math. Actually, we don't need vector math. Math. We'll do exponent. Actually, power is the right one. Our base is going to be that, and our exponent will be -1. Okay. There we go. All right, so we've got our power. So now let's do geometry. We've got to do a vector multiplication, or vector math. Why is that happening? Okay, math, we'll do vector math. We will do a multiply vector by, it's going to be a scalar, basically. Position is going to go in there. So we've got our position multiplied by, okay, this is all getting real confusing. My UI is getting messed up. So let's go back here. So we've got our input position. Why is my clicking doing that, I wonder? It's not supposed to. What? I pushed something somewhere. Okay. Maybe if I change UI modes. Let's go to compositing and then come back to geometry. Nope, still doing it. Okay. So now let's do, we've got our multiply. We are, can I arrange these? We've got the dist 1 over r here. Position, so we take 1 over r and multiply that by our position. That so this is a vector, position vector. Let's normalize this. Vector math. So now we've got our normalized vector. Okay. And now let's take our geometry and we will do an offset. Let's see if we can do this. Translation. No. Okay, this is something that I always get confused by. Does not support fields. All right, so I can't transform the geometry by a field. So I guess what we need to do then is we need to turn, add our position, and then we set our new position. So vector math, we'll add our new vector to our position. And then that gives us a new vector, which we will set as our position. So geometry right, set position. Okay, and now let's output that. Okay. Okay, so now we have a couple different free parameters here. So we've got our geometry nodes, right? Instances on points. So let's add a group here gravitational force. Okay, and now what we have is we have our, let's see, vector at 0. Now let's go back over here. So now they're being distorted by that. So let's take a look at geometry force. And then here we've got our scalar multiplier. So let's do math. There we go. And now let's grab our value that we're multiplying by. Now if we come back here, geometry nodes, here, if I dial this up and down, it should expand and contract. If I set this to 0, now that's weird. It should not modify it at all if I set it to 0. So let's see if we can figure out why it's doing that. We've got our normalize, multiply, so vector normalize. Oh, this multiply I think is supposed to come at a different point. Okay, so we've got our oh, this isn't supposed to be add, it's supposed to be multiply. Okay, so now let's go back here to geometry nodes. All right, there we go. So now it looks like, yeah, as we increase it, we can see the force increasing. Now, the way that this is set up, and here I'm going to save this, volume gravity. The way this is set up is it pushes them in when it's positive, or it pushes them out when it's positive, because it's a force, but it's directed outwards. Okay. So that's neat. You can see it's totally radial. Now if I move it, you can see it. Yeah, there we go. So that's fun. All right. Now ideally, I would have this already converted over. But we're not gonna, I don't really have that yet today. So we've got our force based on our volume. We've got it all done as nodes. So gravitational force, we've got an arbitrary scaling parameter, we've got our location here. The other thing we could do is here, let's add a geometry primitive, or a mesh primitive. We'll do a nice sphere. And then what we'll do is we will have a single position for both input value, vector, here we go. So this vector is going to go in here. And so now, yep, and we will also take our we'll do an instance on point. Oh, you know what? Here, I'll do this. Do a point. We'll do 1 point here. We will instance on that point. We will mesh our instance. And you see if we make it really big. Huh. Oh, right. I need to join my geometry. So join up some geometries here. So now we've got our nice little geometry here. This is our radius, and when we move it different places, it moves the source of the repulsive gravity. Okay, now I guess the other neat thing that we could do here, let's do attribute, or input, do a constant value, and then I'll make this value linked to the radius. And let's also feed it in there. So now as this gets bigger, oh, that's fun. This is one of my favorite songs on the album. Look at that. Okay. Okay, so now we've got a sphere that, ooh, that's interesting. I wonder, oh. Here, let's center it. And I think we're also running into, I think some of these that are out here, I think those are probably ones that are really close, and we're seeing singularities here. So if we do this distance, let me put a clamp here. Utilities, math, clamp. We'll do a minimum of 0.0001. Actually, I don't actually want clamp. I want a floor. Can I do a floor? Okay, maximum of. There we go. So now it shouldn't explode. So let's take a look again. Yeah. Well, I guess it's not that much better. Okay. So I think the next thing, let's see what this looks like. The next thing I would want to do, although it looks like it's having a hard time with shading it. Yeah. All right, let's go back to preview. The next thing I would want to do is I would want to figure out how we might be able to integrate along a curve. So let's create a new one. Go to geometry nodes, and I think what we need to do here is we need to create a volume. I'm not going to create any points yet, but I think what I want to do can I set a volume in here? I guess I can. This has a fixed resolution, so that's not necessarily going to work, but we we can give it a shot. Um, Basically what I think we want to do is we want to store a new named attribute and then integrate that named attribute. So let's see if I can actually do that really simply. Let's try taking a curve. We'll just do a line. We'll output the curve. Okay, there we go. That's nice. So let's see now. Can I feed? What does this do? Okay, maybe that'll do it. We'll name this as position curve. So we store a named attribute. Let's see if I can accumulate. Actually, maybe we don't need to do that. Let's try accumulating this. Okay, we'll store a named attribute, but our named attribute come from there. Okay, and now I'm going to now instance on this. Do curves to points. Okay, and now not 100% sure that I'm doing this the right way, but we'll increase this. Now let's add a material. And we're going to do a real simple material. Let's go over here, shading. Ooh, it's struggling. Sometimes when I switch the viewport like that, it struggles. I don't even know if you're able to hear me at this point. Oh yeah, it came up with this thing. Well, let's go back to viewport shading, and now we'll name this one. I'm not even sure this is going to do what I want. I just want the color. Materials where I get a little bit confused. So let's go here to material, simple. Yeah, okay. All right, let's try this a little bit differently. The attribute needs to actually be converted to something else. No, that's not the one. Yeah, because it's receiving an attribute which is actually not a color. It's a floating point value. So of course that's not going to give us anything. We actually need to apply color map. I did this just the other day and I forget. Map range. Let's do a color ramp. There we go. That's what I wanted. So we will take value there. And let's do this. Now, okay, so now let's add another point in here. And just for fun, make it look like that. So we should be able to get some differences here. Now, it's not going to be that amazing. And actually, I'm not sure that this is precisely what we want because it's a color. Okay, let's go back to geometry. What did I just click? Nope. So let's see what this looks like. All right. Yeah, that didn't do it. So if I did this correctly, then instead what I should be able to do here. Yeah, okay. So I am getting basically what I want in that it's computing that. And if I do this, then the positions, yep, it is accumulating it. But the X and Y positions are mapping wrong, I guess. Yeah, because it's converting it into a vector. So let's go back. Let's change this. I'm going to have to go in just a minute. I'm going to unmix the vectors. Separate XYZ. guess I need to learn more about how accumulating works, because there we go. So now I've got a color there, but I'm not accumulating. So what I need to do is I need to figure out how to accumulate along this curve and what it means to accumulate, because it looks like the accumulation process is not quite as straightforward as I thought. And I actually thought add the values of an evaluated field together and output the running total for each element. Well, running total for each element. I wonder if I need to do this with an evaluated and index. Anyhow, really what I want to do is I want to integrate. But it looks like that might not necessarily work properly. So, okay. With that, I think I am going to call it a day on this. I didn't get quite as far as I wanted, but I got some stuff done. Really what I wanted to be able to do is I wanted to be able to compute values along a curve, but that didn't exactly work out. So, I guess I'll give a shot at that next time. Okay, thanks everybody for joining me.